Hello everyone. So thank you for watching this lecture video. So this is about topic review overview for two variable discrete distribution. So two variable just come from two factors. We split all people by two facts. Like we split people by male, female, by gender, or by another other one is for grades. Some people A, some people B. So we split all people by the two factors. We can have such a table, right? So we can change this table as a probability. If we divide by total 50, then we can have the probability table. So this probability table is just the joint distribution. We say joint distribution. Okay, for landing variable x, y. So x is grades or GPA, and y is for gender 0, 1, right? Okay. So for the here we have some notation. So if we only consider those, just consider this fact, we put male female together. So then such a distribution is called marginal distribution, right? Marginal distribution for this x, or marginal distribution for y. So means we just consider gender, male, female, some male, female. We do not consider grades, right? Okay. So then, if we have um, two factors, if we only consider consider those people, then we have a conditional distribution, right? So let's say, so here we just consider those people, consider their grade distribution for female, y equals 0, right? So this is conditional distribution. And we also have a conditional distribution that if we just check those x equal 4, so we just focus on those people, like for A students, right? So for A students, grade x equal 4 means grade equal grade is A, right? So for A students, so we can split this gender. Y is female count for so many, male count for so many, right? So once we have the conditional distribution, we can have the conditional probability, conditional expectation, like those things, right? We have conditional expectation and conditional variance. So we have those things, right? Conditional. So we also can have like those things, variance of x when y equals 0. So here y equals 0 means female, right? For female students, we just check the variance for their grades or variance for their GPA, right? And so here we have a covariance. Covariance is this. This equal, we say, covariance for x, y. So this is definition is the same as the discrete or continuous set. Okay, so if covariance equals 0, so we say these two variables are independent. So for independent, we have two definitions. Some is we for probability, we say these two events are independent, meaning like a PA, and on this condition probability, if those probability equal, so then we say A and B are independent. Like this probability for those people, B only consider the B people or consider all the people the same. Then we say this B and A have no relationship, right? So we say A and B are independent. Okay, so now let's say if we have a joint distribution, so we want to find those things like x, and find those y or those conditional expectation. So for x, we can have two ways to find x. One way is we just regard the two variable distribution, right? So x can be 0, so multiply the probability that x equals 0. So we have two cases for y, like x equals 0, we have two cases, 0.1 plus 0.3, right? Or then x equals 1, then check all those cases, and x equals 2, like this, right? So this we regard this is a two variable distribution. So other way is if we only consider x, we can find x's marginal distribution, right? So x can be 0, 1, 2. So forget the y. So x equals 0. Probability x equals 0. So we just check all those cases. So we have two cases put together, 0.4, right? So here 0.3, here 0.3. So we can say that these two methods the same, right? Okay, so for y is also the same. Now we can find y's distribution. So y can be 1, -1. Then probability for y. So y equal 1, we just add them up. So y equal 1, 0.4. Y equal -1, 0.6, right? So this is conditional expectation. So when y equal 1 or y equal -1, this x can be 0, 1, 2. And the probability for y equal 1 is just like this. So we just pick a y equal -1, so 0.3, 0.1, 0.2. So this distribution, a conditional distribution, just like that. But here, one thing we should be careful is this is not a distribution, because total probability is not equal 1, right? So we need to adjust this. So we just try to multiply some constant to make the total probability equal 1. So we find this constant is just 0.6, right? So we just divide by 0.6, divide 0.6, 0.6. So this become a distribution. So we can so the conditional expectation is just the expectation for such a distribution, right? Okay. So for those find those things and then check whether they are independent or dependent. So find the covariance x, y. We just use the definition just like this, equal xy minus x times y. So just find xy, right? So xy, so suppose xy. So we can find xy, so forget 0, so 1, 1. So x times y equal 1, 1, 1. So the probability is 0.2. Okay, so x equal 2, y equal 1. So xy equal 2, so so x equal 2, y equal 1 is this, right? So plus x equal 1, y equal -1. So multiplication is -1. So there's a probability is 0.1. So x equal 2, y equal -1. So there's equal -2. So the probability is 0.2. So this is just the way you find it is x, y. Okay, so then find this probability. So such as is we just check visual case. So y equal 1 and x larger than 1. So we just check again what is those cases. Y equal 1. So x larger than 2, we have two cases of x equal 1 and x equal 2, right? So such a probability is 0.2, 0.1. So such a problem, I think is easy, right? Okay. Okay. So then we can find like conditional expectation or conditional probability, right? So let's check this conditional probability. So let's say so if y equal -1, so we need to find this conditional y equal -1. So here x equal 0, 1, 2. So x equals 0, 1, 2. So y equal -1, x equal 1. We find this equal 0.1. But this probability is not equal 0.1. We just say among this condition. So among this condition is x. This is 0.3. Yeah, 0.1, 0.2. So again, this condition, this is not the density, not the distribution. Okay, so try to make this as a conditional distribution. We need to divide by 0.6. So here 0.6. Okay, 0.6. So we find this probability is 0.6. No, 0.1 over 0.6 equal 1 over 6. Right? Okay. So for those just a conditional expectations, so we need to find a conditional distribution. So when x equal 1, let's say so y can be 1, -1. So when x equal 1, y equal 1 is such a probability of 0.2, right? So when x equal 1, y equal -1, such a probability is 0.1. So this again, like this is not a distribution because total probability not equal 0, so we should divide by total 0.3, 0.3. So there's a distribution just like that. So y can be 1 or -1. There's a probability. So equal 2 over 3, 1 over 3. Then we just find this expectation, right? From such a distribution. From this distribution, find expectation. Okay. So once we understand those notations, such a problem is really easy. So here find values for x. So we just focus on x. So maybe we can check the distribution for x. Right? So x can be 0, 1, 2. Then probability for x equals 0. So we just check all the cases for x equals 0. So we say only there's a case x equals 0. So check all y. So we find this equal 1 over 6. Okay. Then x equal 1. So x equal 1, we have two cases. This x equal 1, x equal 1, right? So we just put them together. So this equal 12. So 1 over 12 plus, so should be 3 over 12, right? So x equal 2. So we have these three cases. X equal 2, x equal 2, x equal 2. So this equal 12 over 6 is 1. Okay. This is 4 and 2, right? So the distribution for x is just like that. So we can simplify this distribution for x. So this distribution is a marginal distribution, and the probability, maybe we just can use 12, yeah, denominator 12. So here 12, 7, here 3, here 2, right? So by now find the values for this x is very easy. So for this problem, again, let's find the conditional values. So we just check, okay, distribution for y, conditional distribution. Okay. So y, so when x equal 1, when x equal 1, we have only two cases, right? When x equal 1, y can be 0, 1. So the probability is, so y equals 0 is 0, 0, 5, and 5, 0, and x, y equal 1 is thus. Okay, so this is not a density, this is not a distribution, so we need to adjust. Okay, so 0, 1. So we just make the total probability equal 0. So total is 0, 0, 5, 0, and 0, 1 to 5, right? So add them up, total is thus. So 175. So we can put this as 175. So here's 50. 175, 50, 175, 125. Okay. So then we can easily find these values. So this is 1, 0 distribution. So we have this, we know this values equal PQ, right? Equal PQ. So P just PQ is just the probability, just equals this times this, right? So maybe we can simplify, but once we have the calculate, we don't need to simplify. We just find these numbers, right? Okay. So here, let's say, so given that, so this means conditional. Conditional, let's say we want to find, calculate the values, the conditional values. It is also says find the values of source variable. So we want, so we denote this as a Q. We want to find the V values of Q, given that under this condition, and there's no tornado in county P, so this means P equals 0. We just want to find these conditional values, right? So when P equals 0, so P equals 0 is just this line. P equals 0. So when P equals 0, Q distribution for Q can be 0, 1, 2, 3, and this is the probability. So here we just copy. So this is 1, 2. This is 0, 0, 6, and this is 0, 0, 5. This is 0, 0, 2. Okay, but this is not a distribution. So we want to make this as a distribution. So we just divide by total. So make the total probability is 1 here. So 0, 0, 6, 0, 0, 5, 0, 0, 2. So what is this? This is 5, right? And 2, 5, right? Yeah. So we just okay. So we can change this as like this. As probabilities 12 over 25, 6 over 25, 5 over 25, and 2 over 25. Let's see. Yeah. Okay. So just like that probability. Okay. So now for this distribution, so find the variance. So find the variance is easy, right? So variance equal q squared minus eq, minus eq squared. So by now such a calculation is easy. Okay. So for discrete variable discrete distribution, always easy, right? Okay. So we can stop here.